Good afternoon, everyone. My name is Eric Paulsen. Thank you for the introduction, Ben. I'm the field CTO for Coder here in the EMEA region. Recently relocated to London from New York City with surprisingly better weather than we've had actually in the States. So it's been a lovely spring so far. I hope you all have been enjoying that as well. As mentioned, I have engineering in my blood. That Panama Canal bit, right, controlled how water flowed. And kept that water inflow to facilitate global trade, right? And really now, as we've modernized our technologies and our systems, really what has become paramount is keeping engineers and developers and data scientists in flow and reducing as much friction as possible to let that productivity continue to flow like water in the Panama Canal. And not only are we discussing human engineers as well, but nowadays we're starting to discuss agentic AI systems and how they interact with human engineers and where we put those agentic systems within the enterprise. So this is really facilitated by a cloud development environment. I've been in the space for about 5 years now, prior to Gartner even creating the term a CDE. So it's been incredible to see the change so far. So what we have seen across the industry is a sort of a discrepancy between different ways of working in the enterprise, whether it be writing code locally, and doing that could be potentially insecure with data exfiltration risk, having those engineers configure those machines and go through pages and pages of a Jira checklist. And then as well, it's difficult to observe those laptops and understand the processes that are running on those machines, right? We had a customer in financial services who did not allow Docker in the firm because they could not oversee Docker processes that were running locally on the machine. Of course, we all know the dawn of VDI. It's been in the industry for decades now, names like Citrix and Horizon. These environments are also where engineers are working inside of, but that can lead to high latency depending upon where the engineer sits relative to that hosted environment, creating a poor developer experience, and sometimes they're not quite flexible or they're fully ephemeral, so the engineers have to reconfigure those VDIs every time they log back in. And they're pushing all that code up to the cloud where CI/CD and ultimately production live, right? What we've also seen are sort of a more shadow IT approach where we have pockets of engineers saying, hey, I'm just able to build an EC2 instance. I run VS Code as a remote binary on it, and I can open it up in the browser. And I get a lot of those same productivity benefits by having a virtual machine to work off of instead of a laptop. But if you think about that approach at scale, hundreds or thousands of users, right? How do you standardize that process? How do you trust that hundreds of people can click around your AWS console and configure infrastructure? As well, from a governance perspective, how do you make sure that those instances are turned off so we can work within the FinOps guardrails that finance has put in place? As we know, the cloud is just getting more and more expensive. So these are the three main ways that we are seeing development currently being done in the enterprise. And as I mentioned, right, it's leading to developer unproductivity. We see not a lot of time saved when it comes to VDI-based development. And just overall, that unstructured provisioning of infrastructure is becoming quite inefficient. As well, as we continue to move into a more connected world with data really becoming a lot more of the proprietary side of the business. Of course, here in the larger EMEA region with GDPR and data residency requirements, it's very much in the business and the CISO's interest to make sure that they are compliant and reduce risk as much as possible. So with a cloud-based development environment, what we're effectively doing, and this is not just Coder, there are other vendors in the space as well, and there's even built-in solutions that we've seen across our customers as well, previous to bringing in a first-class CDE, is moving the developer device or the compute infrastructure to the cloud. And by cloud, I mean the AWS public cloud, Azure, Google, or on-premise clouds that are kept within private data centers. Or the dev environment lives next to the CI/CD pipeline. It lives next to the version control provider. And what this leads to is just a more improved developer experience, right? We can now define dev environments as code through infrastructure as code paradigms such as Terraform. And since these development environments live next to these services, these data lakes, these Git repositories, it's a much more low latency connection from my workspace to download that data or that repository. And since these are predefined templates or workspaces as code, a new joiner to the team or me switching over to a project means I can commit code on day one because I don't need to uninstall Python and Java and reinstall different binaries on my machine to make sure dependencies don't conflict. And what this leads to, just generally speaking at the business level, of course, is a faster product to market and time to value. And we've seen this across customers in the space where they have improved developer retention. It's easier to keep that talent, especially when that talent is paid quite well. And with the dawn of agentic coding experiences, what we're realizing is that cloud-based development environments really don't need to do anything much more different other than continue to provide the infrastructure that we're provisioning for human engineers and now supply that infrastructure as well to AI agents. So we are the delivery mechanism, and we are the foundation for securely deploying not only a dev environment for a human engineer, but a dev environment for an AI agent where it can operate and iterate with enterprise context and code and doing that in a secure way. And what we're seeing now is, and I actually had a customer say, what we actually envision is not engineers going to the IDE to write the code, but in the future going to the environment to see what code has been written. So a developer can now start to see oversee, I should say, many different AI agents. These AI agents could be considered junior developers working on small first issues in the repository, dependency bumps, small bug fixes that take away a lot of the time from a senior engineer who needs to work on a more complex task or implement a nuanced piece of architecture. And so with these CDEs, right, there's a boundary between the human engineer and the agent, with the agent siphoned off to effectively a non-privileged process in the Linux context, right, to a specific namespace to keep it safe and separate from the human engineer, right? And CDEs can really benefit from a lot of the innovation that's already being built in the market, right? Claude Code, OpenAI Codex, and now some other open source agents as well, such as Block's Goose, where you can call private models instead of the public data sets, right, and LLMs. And as mentioned, right, the AI that you're going to implement within the enterprise needs to use the models and data inside of your enterprise that is proprietary to your business, and that is compliant with the larger macro regulations at play, especially here within EMEA. So thinking about how do you implement these systems to fit into those constraints. So from a CDE perspective, it's a workspace, it's a development environment, it's a container, an EC2 instance. It could be a virtual machine hosted on VMware. It could be OpenStack, right? But ultimately, it's a developer and a coding agent or many coding agents coexisting in an environment where the developer has more of that lateral movement within the container. They have network access and file system access to do the job that they typically do. And then the coding agent is sandboxed effectively to a specific working directory under a unique PID within the Linux context. So that ultimately these agents can stay productive and access the files that they need to without, we hear the term hallucination, and going off and doing things that could be unexpected. So what these CDEs provide agents are three things, right? It's context. Running an agent on your laptop sounds great. It's a fun demo and way to learn the space. But if you actually want it to be productive in the enterprise context, it's going to need access to those specific services, those private Git repositories, and data sets that you're working with. And as well, those agents are going to need binaries and tools that are unique to your enterprise dev environment in order to conduct those workflows, right? You might not necessarily have access to specific tooling on your laptop locally, right? Which hinders the agent when it runs locally. And then I continue to mention boundaries, right? How do we isolate agents into a sandbox? And just largely speaking, how are you going to implement agents inside of your enterprise, right? We don't see a lot of customers who feel comfortable running AI agents locally, right? And they don't want those agents accessing enterprise data, but also having public internet access to publicly available models, right? And then as well, this helps agents optimize themselves to be more productive, right? They're working on and learning on enterprise data, which means that they can be more and more productive through the iterations of the workflow. So ultimately, it's a dance, right? It takes two to tango, both human engineer and AI agents. I'm not going to sit on this stage here today and tell you that CDEs are moving in the direction of fully autonomous dev environments. That's a conversation for the future. But ultimately, we believe that there is a way that human engineers and AI agents can interact that is productive and safe. So as I mentioned, right, small to medium-sized code changes to help the agents iterate and continue to be productive, whether it be a minor UI or UX bug, or just simple documentation, right? Sometimes engineers are so busy programming and actually writing the logic that they don't spend as much time as they should writing good, clean documentation that allows folks like us to consume and build services, right? We've all had experiences with bad documentation and that leading to not a very productive experience deploying software. And then as well, unit testing, right, which is so important and vital for the stability of software. These AI agents can at least build and scaffold a unit test for you while you continue to iterate on the programming or I should say the logic. So I represent Coder. We are an open source, self-hosted, cloud-based development environment, and we believe that we're building towards this next iteration and era of both human and AI agents working together in a safe and scalable enterprise context. So both human and agents coexisting. You have governance and oversight from a enterprise perspective, knowing that these agents are running a standardized configuration, a standardized set of cursor rules or Claude.md that you and all of your colleagues are all consuming, knowing that your agents are working in the same way, right? So the use cases for Coder and CDEs at large is an improved developer productivity and experience within your companies. Over the course of my 5 years at Coder, there really wasn't much of a thing called developer productivity or any initiatives as such in the enterprise, and now I'm starting to have conversations with customers where I'm part of the developer experience initiative at this financial services firm. I have a top-down initiative from my CIO or CTO to improve my developer experience, right? How do we quickly onboard new joiners or people who are project switching across different tech stacks where they might be working on a Windows-based .NET application, but then they also need to pivot over to Linux in order to build something that might be more native to the cloud, right? As well, how do we make sure that these dev environments are secure and standardized, right? How can I be sure that every time that they're built in the same way every time and they reliably start up with the tooling and packages that are required for these engineers, both AI and human, to be productive? And then as well, how do I potentially consolidate my tool sprawl within my company, right? I'm speaking to a large bank here in the UK. They have 10 different ways to install WSL in the bank, which is creating a very fragmented developer experience, right? That's inefficient. They view a CDE to be the way to entirely remove WSL and just allow for a Linux container or virtual machine to be provisioned by a platform like ours, and ultimately have a Linux native coding experience while still also using a Windows client, right? Because we can access a terminal in the browser or an IDE in the browser. From a compute perspective, right? Sometimes these laptops are quite limited from a CPU and memory perspective. Of course, with more data science specific workloads and model building, you need access to more high performance compute. A lot of that lives within the corporate data center, right? So how does my dev environment get access to those NVIDIA chipsets, right? And so optimizing these workflows to use that high performance compute is also a key use case. And then VDI, right? There's initiatives to move away from VDI, and what are some ways that you can do that specifically for software engineers and data scientists. So creating a browser-based coding experience through VS Code, Jupyter Notebook, really augments and can sometimes replace the need for virtual desktops. And then, as I mentioned, right, all of this lends itself to a foundation that allows for you to deliver agentic processes in your software engineering environments. So we are an open source product. We have a pretty robust presence within the open source community. Not only is our main CDE itself open source, but we have other technologies that we've put out into the community. You might have used it, Code Server or VS Code in the browser. That is pretty much, or was the dawn of our company, and we decided to build an enterprise-grade platform around remote coding. So check us out, coder.com. We actually just did a rebrand today, so you are seeing a brand new site. But that's pretty much all I had. I'll take any questions if anyone is curious, but thank you for your time and attention.
Just a quick one. How are you finding the developer experience with latency and things? Because obviously most people are working at home, or lots of people are working at home these days. Is that something you have to handle or consider?
Yeah, so latency is very much, of course, always a question when it comes to remote development. I'm not going to sit here and say we solved the speed of light problem. But that being said, it's all about deploying infrastructure local to the engineer, right? We have EU West here in London, or a data center in the office that is close to the engineer, instead of having the engineer connect across the pond to their infrastructure, say in the States, right, or in the Middle East. As well, Coder ships with a WireGuard networking stack. So we actually support point-to-point or direct connections over the UDP protocol. So once again, we're pushing the boundaries as it relates to types of connectivity to allow for a more low latency experience. As you know, Zoom and Microsoft Teams calls that we use today leverage UDP. And so we're bringing that experience to remote development. Does that answer your question? Yeah. We had a couple questions over here too. Yeah.
Get my steps in today.
Cheers. We've got a requirement for Mac OS development, Xcode developers. So the only way we've been able to solve that for this type of situation would be like a Mac OS workload EC2 in AWS. Have you got any? Have you come across this before, basically, like for Mac OS development?
Yeah. So for those that may not have heard, the question is about Mac OS development. Is that a use case that I've seen or is used with CDEs? And not too common, unfortunately, just due to the limitation that Xcode does not support remote-based development, right? So VS Code has the SSH layer and that SSH extension to connect to remote computing environments. With Xcode, you have to run it on a Mac OS device or a licensed Mac OS operating system. So there would have to be some form of emulation there to allow for that to be exposed to a client, right? So it's a bit of I'd say a rough around the edges use case, but.
Hi. How do you support like mob programming? Because all the sort of solutions that we have used are essentially rubbish. In terms of resources they require and latency, and they become more of a hindrance to the sort of pair programming, mob programming sort of.
Yeah, could you define MOP programming specifically?
Where you have multiple people sort of working on a single code base. Maybe they can look at other areas of the code than I'm looking at, just to get a bit more context that they need. But we're all working on the same sort of code.
Yeah, so from our perspective, right, each development environment is scoped to an individual engineer. As we might know, the VS Code Live Share extension allows for that pair programming experience. Same with the JetBrains Code with Me offering. But generally speaking, you can consider a CDE to be a laptop or developer device in the cloud. So there really isn't a shared workspace model that we've implemented just yet. And that's, from a security perspective, right? How do you determine who is executing that commit to the code base, right? So it's a great question, and one that we get quite often. And we're actually building towards that, but I don't have enough information yet to share. So does that answer your question? Yeah. I think we had some questions over here, or I might be out of time. So.
Hi. One of the big issues that I've heard of and had colleagues complain about is they lose internet, they lose their code that they haven't committed, or they're working on a workspace and it restarts and they've lost all of their work. They can, yes, you should commit regularly, but just because you should doesn't mean you do.
Right.
One of the big things here is also that if you are having, you need to get something out fast and the workspace is just not cooperating, or the pipeline for building it's down, you're essentially stuck. You can't really do anything.
Right.
How do you handle that? Because losing code that you've spent even an hour working on, where you've done a lot of work, is infuriating, but it's also really counterproductive for that
productivity.
Workflow. Yeah.
Yeah. So cloud development environments, generally speaking, allow for persistence. So in our context, we're simply running Terraform to build, say, a Kubernetes pod or a virtual machine that would have a network file share or boot disk or persistent volume claim attached. So as I mentioned, laptop in the cloud, you can literally save your work in progress code to the home directory. And then, if you get booted by a Kubernetes node, it's over, it's out of memory. That persistent volume claim will still exist and have your code persisted. Or as well, granted, if the virtual machine is fully deleted, you might lose that boot disk. But generally speaking, we do allow for some persistence in case the container is taken down. So in the Kubernetes context, that would be more resilient, right? You have a PVC that is sort of separate from the compute, which would allow for remediation of situations like that. Did I answer your question there, by chance?
Mostly except the local, if you lose your internet, for example.
Sure.
You can't work.
Yeah, and that's quite common of a question, but ultimately, I guess the question back would be, how often are you losing internet, right? In certain cases, that might be quite common if you're traveling a lot for work. We have customers that require physical presence in the building to connect to the network. So ultimately, they can't write code outside of the premises. So it just depends upon the use case. Coder itself, we support a two-way file sync, so you can make changes locally and then push those changes up to the remote. But that also opens up to the inefficiencies of local development and the risks associated. So I would say it's a compromise or a trade-off. Yeah. Any other questions?
Yeah, just one more.
Very last one. And I think
Thank you for an interesting talk.
Oh, yeah. Oh, okay. Yeah.
One question. I just wanted to understand in the context of Coda, does the code leave your client's environment? Does it live externally? You just mentioned you've been talking to a large financial institution, and I know that's a regulated environment where we pretty much don't allow code to leave our environment. So
Right.
when working with Coda, where does the code actually, does it leave the premises or not?
Yeah, so Coder itself is self-hosted entirely, both the control plane and the development environments that it creates. So the code would never leave the premises, to answer your question. And it can run in offline or air-gapped environments, right? There's no callback to coder.com. We're a simple Golang binary that you can run on Kubernetes, and you can bundle your Terraform binary and other providers that you need and keep it fully isolated. So I wouldn't trust Coder to host a client's data as well, or that's why we took the self-hosted approach. we're not a large multinational company, and ultimately, from a startup perspective, it's easier to tell people, hey, you're responsible for your own security, and we've architected Coder in a way that allows for the platform to really simply inherit the security apparatus that's present within these firms. So,
Thank you.
yeah. Okay. Well, if that's all questions, thank you for your time. Appreciate the questions, and yeah, have a great rest of your show.
Woo!